So this is the second question from the Love Pupper DSA sheet. The question is find the minimum and the maximum of the array with minimum comparisons. So let's first open the link and see the problem statement properly. So this is the problem statement. Uh, the problem statement basically says that write a C program to return the minimum and the maximum of the array. Your program should make minimum number of comparisons, right?
We have to find out the maximum and minimum of an array using as less number of comparison. The most naive approach from the problem is that let's say I have 4 elements, that is 5, 7, 10 and 3. I want to find the minimum among them. So I am writing a variable mean and I am initialize the variable with the first element of the array. So now my minimum is 5. Then I am traversing through the array and the next element is 7. I am comparing 7 with 5. 5 is still minimum, so I keep traversing. 10. 5 is still minimum, so we are traversing again. Now 3. 3 is less than 5, so we are initialize, we are assigning minimum variable with 3. So thus we get the minimum as 3. Now the important point is uh, how much comparison we make. So at first we initialize minimum variable with 5 and then I compare it with the rest of the element. So here in the array there are 4 elements, that's why I make 3 comparison. That means if I have n elements, then I need n minus 1 comparison. In the similar way, if we want to find the maximum of the maximum element, then we also need n minus 1 comparison. So the total number of comparison in this way, if we want to find, then the number of comparison will be 2n minus 2. This is order of n. But I want to reduce the number of comparison to find out our minimum and maximum element. To reduce the number of comparison, there is a way. So this is my array and I am taking two extra array, one is mean and other is maximum. Here every time I will choose a pair. Every time I will choose a pair and I will compare both of them. The minimum between them will come to minimum array and maximum of them will come to maximum array. So after the first comparison, 5 will come to minimum array, 7 will come to maximum array. After this comparison, 3 will come to minimum array, 10 will come to maximum array. After this comparison, 4 will come in the minimum array and 5 will come in the maximum array. Then I will run a loop from 0 index to up to 2 index and I will find out which is the minimum element. Here there are 3 elements, that means after 2 comparison I can find out the minimum element among them, and after two comparison I can find out the maximum element among them. That means that if I have n elements in my array, so every time I am choosing a pair, so the number of pair will be n by 2, and for every pair I am making one comparison. That means here I need n minus 2 comparison. After n minus 2 comparison, I have n minus 2 elements in my maximum array, and I have n minus 2 elements in my minimum array. And among the n minus 2 elements, after n by 2 minus 1 comparison, I can get my desired maximum element. And after n minus 2 minus 1 comparison, I can get my desired minimum element. So the total number of comparison we make in this case is, at first we are making n by 2 comparison, then n by 2 minus 1, and then n by 2 minus 1 again. So total comparison is equal to 3n by 2 minus 2. So this is my optimum number of comparison. But still, though we could found the minimum and maximum element after n 3n by 2 minus 2 comparison, but in that algorithm we use an extra array. Extra array we used for maximum and minimum. Time complexity will reduce, but our space complexity will be of order of n. And now I want that our space complexity should be order of 1. That means we should not use any extra array. So how can we do that? To find out the maximum and minimum element after 3n by 2 minus 2 comparison without using any extra space, we need a structure. What is the structure is all about? We need a structure. Inside the structure we keep a variable mean, and we will keep a variable max. And the thing we did last time, we will do the almost same thing. Let's say I have total n number of elements, and I am checking with a pair. Now we will see that how can we find out the minimum and the maximum of the entire array after 3n by 2 minus 2 comparison without using any extra array. To uh, do do so, we need a structured variable. We need a structured variable where I will keep one minimum and I will keep one maximum. And the thing we did at the last time, we will do almost same thing. That is, we will take pair, and we will compare only the two elements within that pair. So if I have n elements, then I will have n by 2 pairs. So in the first pair, after one comparison, I can see that 7 is minimum and 10 is maximum. That is the minimum of that pair, and minimum of that pair is initially 7, and maximum of that pair is 10. Now I didn't have any value in the minimum and maximum. So after the first pair comparison of the first pair, I am putting this minimum in the structure minimum, and I am keeping this 10, the maximum of the first pair. I am putting this in my maximum. Then we will check for the second pair. In the second pair, the minimum pair, the minimum of that pair is 20, and the maximum of that pair is 25. Now I will check whether this 20 is eligible to become this structure minimum or not. 20 is greater than 7, so it is not eligible to become minimum of the entire array. 25 is eligible to become the maximum of entire array. In the structure variable, the minimum and maximum are the representative of the minimum and the maximum of the entire array. 25 is greater than 10, so 25 is eligible to become the maximum of the entire array. So I will replace 10 by 25. Now I will check the third pair. So in the third pair, minim the minimum pair will be 2, and the maximum of that pair will be 50. Now 2 is less than the structure minimum. That means 2 is eligible to become the minimum of the entire array. So I will replace 7 by 2, and the maximum current maximum is 50, and 50 is eligible to become a maximum of the structure variable, that is currently is 25. So I will replace 25 by 50. So now I have completed the traversing of the entire array. So at the last, in my structure variable, I have 2 as my minimum and 50 as my maximum. Now I will tell that so here in this algorithm we didn't use any extra space, but what is the number of comparison here? So here if I have n elements, I have n by 2 pairs. I will calculate now for every pair how many comparison we are making. For every pair, one comparison is to check which one between the pair is greater and smaller. So one comparison is required for the pair. One comparison for the pair, and the second comparison I need that now I get a, after this comparison I get a maximum pair and I get a minimum of that pair. Now for this maximum I will check it with structure maximum, and for this pair minimum I will compare it with structure minimum. So I need total 2 comparison. So for any pair I need total here 1 and here 2. So every pair I need 3 comparison. I have n by 2 pairs. So I need 3n by 2 comparison. But there is two extra count that we have made. For the first pair, for this 7 and 2 10, for this pair we actually didn't, we only compared these two, and the minimum of them we put it in my structure minimum, and maximum I put it in the maximum structure maximum. In this case we didn't compare it with the initial value of the minimum and initial value of the uh, maximum. So for the first pair, we actually didn't do 3 comparison, we actually did 1 comparison. So in 3n by 2 comparison, I counted 2 extra comparison. These 2 extra comparison I have counted for first pair. So now the total comparison actually we made is 3n by 2 minus 2 comparison. So thus after 3n by 2 minus 2 comparison and without using any extra array, we can calculate the maximum and the minimum of any given array, and this is the minimum number of comparison we have to make. In our previous example, we saw that the number of element was even. That's why we could make a pair. We can pair the element very easily. But what if we had odd number of element? Then question is that how can we make a pair out of them? Then we will skip the first element and we will make pair of the remaining elements. And initially in my structure variable, the structure minimum and structure maximum, in both of these variable I will assign this first element. So that means here I didn't make any comparison, I am simply putting the first element of the array as my structure minimum and maximum, and then I will run my algorithm as I did before. So here when I have n elements, I make a pair out of n minus 1 elements. So the number of pair is n minus 1 divided by 2. And for every pair I am making 3 comparison. So the total number of comparison when my n is odd is equal to 3 into n minus 1 divided by 2. That means 3n minus 3 divided by 2. Now it doesn't matter whether my number of element is even or odd. When n is even and when n is odd, we can find out the minimum and maximum element from an given array within 3n minus 2 comparison without using any extra array.
Okay, now let's try to implement the code. We will recommend you to try to implement the code by yourself and then come back to the video to clarify that what you have done is correct or not. Okay, or start the implementation. I will make an array first, and the maximum size of the array will be max, and n will be the size of the array which will be provided by the user. Okay, now let's put a message to user that enter the size of the array. Okay, now let's take the size of the array input and store it in n. Now take the elements of the array one by one. Okay, from i0 to n, take one by one elements of the array and store it inside the array. Now before that, put a message to the user, enter the elements of the array. Okay, great. Now after taking all the inputs, we have to do the actual thing, which is find the minimum and the maximum from the given inputs, right? Find the minimum value and the maximum value from the given input. Okay, now I'll make a function find min max. Okay, and this will take the array and the size of the array, and this will return the minimum and the maximum value of the array. So if it has to return two values, right? So we have discussed in the explanation that we will make a structure. Okay, so I will make a structure which the name of the structure will be pair, because it will contain the pair of minimum and maximum of the array. So the members will be min and max. Okay, this min will contain the minimum value of the array and this max will contain the maximum value of the array. Great. So this function will return a pair type value, right? So after returning the pair type value, we will store it in another pair type variable named m or whatever you like. Then we will output the m dot min and a space and m dot max. Okay, now also put a message here that min and max. Great. Now let's try to implement this find min max function, which is the actual part of the code. So return type will be pair and find min max, and it will take the pointer of the array first and the size of the array. Great. Now after this, what we will do, we will make a pair type variable here also, and we will name it until now. Until now, it now variable has two members, until now dot min, until now dot max. So as we discussed in the explanation that we will have two scenarios, right? The n could be even, n could be odd. That means the size of the array could be even or size of the array could be odd. Okay, and basing on the size of the array, we will make the pairs, right? So at first it is important to check the size of the array, right? So the first thing what we will do here, we will check the size of the array. Okay, if the size of the array is even, we will do something, and if the size of the array is odd, we will do something. So if n modulo 2 equals to 0, that means the size of the array is even. If the size of the array is even, what we will do, we will make pair from the first two elements of the array. Okay, we will make pair from the first two elements of the array. So to make pair from the first two elements of the array, we will first check which one is greater, a of 0 is greater or a of 1 is greater. Okay, if a of 0 is greater than a of 1, what we will do, we will initialize the until now variable. Okay, the maximum of until now variable will be a of 0 and the minimum of until now will be ARR of 1. Great. And what if this condition is false? That means ARR of 1 is greater than or equals to ARR of 0. Then we will do the reverse thing, that is we will do the opposite thing, that is we will make the minimum of the array until we will make the minimum member of the until now ARR of 0 and the maximum member of the until now ARR of 1. Okay, we are done with pairing. Now we will make another variable I, which is the variable of the loop. Okay, the loop will start from the value of I. Okay, so we will initialize the I into 2. Okay, now this was the first case, right? If the size of the array is even. What if the size of the array is odd? Then if the size of the array is odd, then we will come into this else, and as we discussed in the explanation, we will set the minimum we will set the minimum member of the array and the maximum member of the array both as arr of 0. Okay, and set the I to 1. Great. Now let's run the loop. Okay, the loop will start from the value of I, and I is already initialized here, so we have no need to so I am putting the initialization portion of the for loop empty. Now let's check the condition, which is I less than n minus 1. We will run the loop until the value of the I is less than n minus 1, and we will increment the I each time by 2. Okay, now inside this loop, what we will do, we will check that if the ith index of the array is greater than I plus 1th index of the array. If this is true, then what we will do, we will check that the ith index of the array is greater than until now maximum or not. Okay, if the ith index of the array is greater than until now dot maximum, then what we will do, we will replace the until now maximum with the maximum value, that is arr of I. Okay, and we will also check if the arr of I plus 1 is less than until now minimum. Okay, then the until now minimum will be replaced with arr of I plus 1. Okay, and what if this case is false? Okay, arr of, what if arr of I plus 1 is greater than arr of I? Then what we will do, we will come to the else condition and do the opposite thing, right? If arr of I is I plus 1 is greater than arr of, sorry, until now maximum, then we will replace the until now maximum with array of I plus 1, and we will also check that array of I is less than until now minimum or not. Okay, if that is also true, we will change the until now minimum to array of I. Okay, then after this we are complete with our implementation. Now let's return the until now variable. Okay, so after returning the until now variable, it will be copied to this m. Okay, and we will get the output. Now let's try to compile the code and see what happens. As we all know that it never happens that in first compilation the code runs. What mistake I have made, find min max is not declared in the scope. What I have done, oh, I have forget to put a semicolon here. Oh, semicolon is a very dangerous thing. Now let's see, again an error. Where is the error? I forget to put a semicolon here also. Okay, I think after this I will be done. Okay, finished. Now let's try to check some test cases. Okay, let me zoom the terminal for you little bit. Okay, so I will give 5 elements, and they are 5, 9, -2, 6 and 4. 1, 2, 3, 4, 5. Okay, so the minimum is -2 and the maximum is 9. Okay, this worked fine. Now let's try to compile it again. Let's try to run it again and check some other test case. Okay, Let's zoom in, and this time I'll check with 6 elements. uh, this 5, this minus 2, this minus 9, this 6, 8 and 10. Okay, the minimum is minus 9 and the maximum is 10. Okay, this is working completely fine. So thank you for watching the video and have a good day.